Hey, Miss Sparks.
Hey, Adriana, are you feeling any better?
Yeah, I am.
Oh, good. Glad to hear it. Hold on.
Yeah, me too. Both my parents are down with the flu, though, so
Oh, Lord, have mercy.
I know.
Ugh,
But I think I just have a cold, so that's good.
yes. I'm glad that that's all because the flu is terrible.
Yeah.
Um, Obviously, I know you don't have a lot of the handouts um, that we did, and I could, like the one that's on the screen, I could actually send you that one, but we added some problems to it that wouldn't be, on this one, but I can email this one to you so you could be working on it. And it is all multiple choice, so that's kind of good. So you can kind of be like, "Ooh, okay, I got it." And the whole first page is nothing but like calculator work through that probability thing. But
Awesome.
do you feel comfortable working through that on your calculator? Because I at one point you did have a couple questions on exactly how to do that, and I just want to make sure that you feel comfortable with that now.
Yes, ma'am.
Okay, good. Well, pretty much 1 through 10 are that. So let me get that. Let me get that at least emailed to you,
Okay.
and then we can. What I would like to do, I think while I'm emailing that, I might email. We did a quote. It was supposed to be a scavenger hunt, but instead of doing a scavenger hunt, I just went up front and like put up each of, what the stations would normally have been. And then we went around the room by table groups and just let each table group be responsible for being the people that had to work that one but everybody had to do it. They were just the ones that had to walk through it on the board, if that makes sense.
Okay, makes sense.
So let me get let me get that emailed to you so that maybe we could even be talking about those, because everybody said how we went through that yesterday really helped them with 6.2 over the weekend.
Okay.
And have
You
you had
guys
an
watched the
opportunity to
video.
watch that yet?
I did, and it made absolutely no sense to me.
Okay. Everybody said I didn't go through everything yesterday. I'm going to go through parts of it tomorrow, but I just wanted to just absolutely, cover everything about it, you know,
Okay.
everything about that one section yesterday, and then we'll add to it tomorrow and do some of the review. But I just felt like mastering it would be better. Okay. All right. I'm getting ready to email you. So I either have to sit down or spit out my gum.
Mhm.
Here are the
I'm so
PDFs.
sorry. I actually sound disgusting. I have like not spoken to anyone in the past few days because I sound so gross.
Oh, you don't sound bad.
Uh,
You, you don't, I mean, I was, not anything personal. I was expecting so much worse because some people just, woo.
well, I was texting Alyssa because she's not in any of your classes, but she was out for about a week from school because of the flu.
Uh huh.
And she was telling me that, like, the symptoms I was having were similar to what she was having,
Yes, ma'am.
but I'm pretty sure it's just a cold because I woke up this morning feeling a lot better and I don't have a fever, so.
Yeah. I, okay, I can't find it. That's bad. Um, well, that's good that you kind of were able to sort of knock it pretty quick because it has been
Yeah, I know my immune system was definitely fighting something.
for sure.
Yeah, I could feel it. I was like, no, I'm not going to succumb to this.
Good.
Because I have volleyball this week and next week, and then I have a really big tournament. So I was like, I am not willing to go down.
You go, girl. Stay strong.
Yeah, I have practice tomorrow, so hey, fingers crossed.
Yes. Practice tomorrow after school.
Yes, ma'am.
Okay. All right. And then once again, one of the things that I'm sending you, it says Chapter 6 Review 2018 Classwork PDF.
Mm-hmm.
Remind me tomorrow to give you the updated one because it is missing, hang on, 3 major problems that have 4 sections to them. So, but obviously this would be plenty of work for today. You know what I'm saying?
Uh-huh.
If we
Is this
do,
gonna be due at the test time?
um, we're giving so much review this time that if somebody just kind of hands in whatever they've worked on for review, I'll be happy with for this week. And what I've been doing more than anything is just taking a glance at what notes you've taken and what you're doing in class
Mm-hmm.
so that you can hang on to everything that you're writing with so that everybody, because so many people have missed different things that
Mm-hmm.
we're trying to just review to make sure everybody's on the same page. So in the midst of doing that, it seems like a lot of people have different reviews. Does that make sense? So if I can just see that you've worked on it enough that you feel comfortable, that's really what I'm looking for. Does that make sense?
Okay, it does make sense.
Okay. I'm sharing and sending. So you should have it in just a minute.
Okay.
But since
Yeah.
nobody else is really with us,
Mm-hmm.
I am going to go through what I went through in class yesterday first to hit a couple of those and then go back to that. Is that okay with you?
Yeah, sounds fine.
And if somebody joins us, will you give me the heads up because I won't be able to see? Okay. You wouldn't necessarily have to print everything out. I just wanted to make sure you had a copy of what we did.
Okay.
Since you and I are going to be actually working through it, if I don't know if you just wanted to store it or put it in Drive or whatever you want to do. Don't let the top part, can you see it okay?
Mm-hmm.
Okay. Don't let the top part throw you off because, like I say, this is a scavenger hunt. So technically, that's the answer to a different problem.
Mm-hmm.
Okay. So on these, the find the probability of X successes in N trials for the given probability of success P on each trial, round to the nearest hundredth of a percent. What that kind of says in people terms and not mathematician terms is a binomial distribution, which is is 60% of this chapter. Okay. A binomial distribution is that type of experiment in statistics where there's only 2 possible outcomes, thereby the name binomial, like bicycle too, right? So there's a win and a lose. There's a fail and succeed. There's a yes, no, true, false. Only 2 possibilities, heads, tails, that kind of thing. Does that make sense? So there's really only 2 possibilities. And the percentage here, the percentage is what percentage of that probability of success is. And then the number here is the number of trials. And they're asking, what is the possibility that we'll have 4 successes in 6 trials if the percent of probability of success is 30%? That's what it's asking. What that looks like to you and I, like how we would plug that into a calculator or to break it down, it would look like 6, choose 4. And then you would put that percentage in this parenthesis and raise it to that choose 4 percentage or that choose 4 number. Then what is the difference between 100% and 30%?
70%, right?
So that would go in this second box. And the difference between 6 and 4 would be the exponent for this second one. And that's really all that is.
Okay. That's a lot to remember.
And once you do a few of them, which we're about to do, you'll see that it becomes easier. The other thing that I want to show you, and they were happy that I showed them this yesterday. Do you happen to have your Pascal's triangle with you?
Yes.
Okay. If you would go down to the row 6 where it says 1, 6, do you know where I'm referring to?
Mm-hmm.
Okay. If you'll count over, starting with the 1, if you'll go 0, 1, 2, 3, 4, tell me what that number is.
It should be a 15.
15. If you were to put in your calculator this 6, choose 4, you should get 15.
Okay. I'm going to check just to make sure.
Please do.
Yeah.
Okay. So what I want to say, and what, maybe I'm an old-fashioned girl, I don't know, whatever. Pascal's triangle is just this whole choosing, that whole probability thing. If you prefer hitting math, arrowing over to probability, arrowing down to choose, NCR, and typing in those numbers, great. I'm plenty happy with that. There are some problems on here where our Pascal's triangle aren't going to go far enough in to do it. So you would have to do it. But if you prefer using the Pascal's triangle, then go for that. Just always remember that when you're starting at that one position over to the far left, that's a 0. So when you're counting, you're not counting 1, 2, 3, 4. You're counting 0, 1, 2, 3, 4. Does that make sense?
Mm-hmm.
Okay. So now, if you want to, in your calculator, put in 15, open parentheses, 0.3, close parentheses, raised to the 4th power, and then arrow over 1 to make sure that you're coming down back so you're not staying superscript. Parentheses, 0.7, close parentheses, raised to the 2nd power.
Mm-hmm.
And then hit enter.
Okay.
What did you get?
0.059535.
Okay. Now, this is the percent. So in order to transfer this to a percent, what would you do?
Move the decimal over, right?
Mm-hmm. So your answer is 5.95%.
Okay.
There it is. Yay. All right, let's try this next one.
Okay.
Okay. We have X trials, or X successes, I'm sorry, N trials, and the probability of success is 0.1. So that's going to look like your bigger number goes first, 5, C. So 5, choose, and then 3. So your little number is here. That's the number of successes that they're asking you to calculate.
Mm-hmm.
Let me start over because it's kind of going in between. So I don't want it to. 5, choose 3.
Someone has joined.
Someone's joined?
Mm-hmm.
Okay. All right. Let me just finish this. Okay. 5, choose 3, 0.1, and then raise to 3. And then the difference between 100% and this 0.1 or 10% would be 0.9. And then raise to, and the difference between 5 and 3, which is 2. So your exponents should always add up to be this number right here. And your very first number should be that 0.3. So then you just plug that into your calculator. And once again, if you want to use Pascal's triangle, you can go to that row 5 and count over 0, 1, 2, 3. And whatever number is there should be the number that would come up if you plugged in 5, choose 3 in the calculator, which I believe is 10. All right, I was going to see who joined us. Hey, Emma. Do you have a specific question?
On number 16, and then like the 21 and 22, and those.
Okay, let me look at 16. For the Valentine Day one? Am I looking at the right one?
Yeah.
For 16? Okay. I'm just writing them all down. 16, 21,
22, and like through the rest of them.
Oh, okay. So the coefficient ones?
Mm-hmm.
Okay. All right. So I'll handle those next. Let me just do a couple more of these with her, and then I'll get right back to you. Is that okay?
Yeah.
Okay, cool. Adriana, were you able to plug this into the calculator and get an answer by chance?
Yes.
And what did you get?
0.0081.
Yes. So that's a weird percentage, isn't it? So, because if you get on this one 0.0081, to convert that to a percentage, you're going to arrow over there. So it's literally 0.81%. So it's a weird percentage. But that was the answer.
Okay.
All right, go ahead and write down the numbers for this one. Oh, I'm echoing. Is it echoing beyond?
Yeah, it is.
Ugh. Hold on just a second. I was going to say muting helped. It didn't. But go ahead and write down those numbers, Adriana, and see if you can work that one. And please don't let it echo.
When we plug it in, is X going to be the R?
And choose R. Yes.
Yes. Okay, thank you.
Did you get all the numbers?
Yes, I did.
Okay, cool. Yay, I love the echo. Okay, Emma. On number 16. Oh, wow. I have the answer, but I also have a note from Miss Thune that we want to take this one out. And I'm not sure exactly why, but she says I want to take this one out. But the answer is B, 22,350. And basically what it is you're actually taking the number of politicians that are giving Valentines to each other, and then you're subtracting themselves out.
Oh.
So you're taking the 150 times 150 and then subtracting 150 out because they wouldn't give a Valentine to themselves.
Mm-hmm.
Does that make sense?
Mm-hmm.
So we wouldn't obviously give one like that on the test.
Okay.
But you're looking at 150 times 150 and then minus 150.
Mm-hmm.
And it should give you that. And it's a permutation.
Okay.
So I was like, oh, I'm glad she wrote me that note because I probably wouldn't have thought about that being weird. And then down here for 21, right?
Mm-hmm.
You don't love these, Emma?
Well, Brennan tried to teach me how to do them, and I tried watching the other video, and I just don't know.
Okay. Let's see. Do you I'm gonna show you something. Hang on just 1 second. Okay, this is Pascal's triangle to the 5th power, and number 21 is raised to the 5th power.
Mm-hmm.
Okay. So Miss Stone, now I use this because I need simplicity. She's way smarter and obviously way not as lazy as I am. And so the expansion, basically this row right here is the same as this row right here. Okay. And so you can use that NCR thing all the way across.
Yeah, that's how Brennan was teaching me, but it like
the NCR thing.
Yeah, but there's like so many different things. And I feel
Right.
like it's a simpler way.
Okay. Well, that's why I personally like Pascal's triangle, but let me show you how they correspond. Okay? So hopefully that will connect. If you were just to plug in 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5, this bottom row here, you would actually, for each individual ones of those, you would get 1, 5, 1, 5, 10, 10, 5, 1. That's the actual value for those if you plugged them in all by themselves. Okay? So that being said, the next thing that you would need to know is when you're expanding a binomial, when you're looking at it, like this particular, when you're looking at them, just in a generic format, we have a plus b raised to the n power. Okay. And this is the first term and this is the second term of the binomial. Okay. But to be more specific, that would be just that generic formula form. To be more specific with this particular problem, you've got x plus 3 raised to the 5th power. X is the first term, 3 is the second term. Okay, and all the way across, either whether you use this or whether you use that 1, 5, 10, 10, 5, 1, or 5 choose 0, 5 choose 1, 5 choose 2, that is going to be the multiplier in front of each term for the answer. What that means, and then what you would do is you would have that multiplier. For me, so the first thing that I do when I'm expanding one is I just write down x to the 5th, and then I would write down 3 to the 0 plus x to the 4th, 3 to the 1st, plus x to the 3rd, plus 3 to the 2nd. So can you see that one is ascending and the other is descending? So x to the 2nd 3 to the third plus x to the first 3 to the fourth plus, we're way down here, Miss Sparks, x to the 0, which technically is 1, 3 to the fifth. Come on. Please write. All right, now, here's where the multiplier comes in. I'm going to go back to this row here, the multiplier. I've got a 1 as a multiplier out in front of this first term. 5 as the multiplier out in front of this term. 10 as the multiplier out in front of that term. 10 as the multiplier out in front of that term. And then, oops, come on. 5 out in front of that one, and then 1 in front of that one. But if I were to type in 5, choose 0, 5, choose 1, I would get all those same values. So it doesn't really matter how you're doing it. But you will have to know how to expand your terms up and down. I don't know if that makes sense. But this first one is going to be x to the fifth. So what is the question asking? It's asking what's the coefficient of x to the third? Well, then I would find x to the third, which is right here. And I've got 10 as my multiplier, but I also have 3 raised to the second power. So what's 3 raised to the second power?
9.
Okay, and 9 times 10 is?
90.
90. So this is going to be 90x cubed. So the coefficient on that is 90.
Okay.
All right, well, let's do 22 together. Okay? All right. Which way do you think you like it better? The choose, the NCR, or the Pascal's triangle?
Pascal's triangle.
Okay. 90% of everybody else really does too. In my class, but I feel like, and I apologize to everybody yesterday because I was like, if I tainted you against the combinations, I'm very sorry. But that's just a lot of writing going on. But the other thing is you obviously wouldn't have Pascal's triangle on an ACT or SAT. So it's also very important. Oops, what happened again? Important to me for you to understand it walks through.
Miss Sparks?
Yes.
I'm going to have to go, so.
Oh, okay. All right, Adriana. I hope you continue to feel better. And the answer key to the binomial thing is the first page.
Okay.
And it tells you how the letters go in order. But actually, since I sent it to you in order, if you want to kind of cover the next slide, you can kind of work through it that way.
Well, can you send me what the answer was? Well, can you tell me what the answer was to the one you had me do a couple of minutes ago?
Yes, I believe that it was 0.1612, which is 16.12%.
Yeah, I got that. Okay, thank you.
Well, and what I want you to know is if you pull up that PDF on your computer, the answer is actually at the top of the very next slide. So you'll be able to check everything if you just go in order.
Okay, thank you.
Okay?
Yes.
All right. You're welcome. Talk to you later.
Bye.
Bye. Hey, Walker. We're about to do number 22 on the packet that I handed out yesterday.
Is it B?
Can you guys hear me?
Yeah, I can hear you. And it is B, Emma.
Yay.
Yay. Walker.
Yes.
I don't know how much packet, but Emma asked me about 16. And the answer for that one is B. And the reason, it's a permutation and you multiply 150 times 150, but the politicians wouldn't have given themselves a Valentine. So then you take that final answer and subtract off 150.
Gotcha.
So, and then we were working on number 21, and I had just worked it out, and the answer was D, 90. And then Emma just told me that the answer for 22 was 256. But Emma, do you care if I work that one out? Or Walker, would you like me to work that one out? Or is there another one you have a question on?
Not in particularly. I'm just trying to go ahead and see a few reviews to try and get the gist of it. But hold on, I'm gonna get some headphones.
Okay. Emma, do you care if I work that one out?
It's kind of cutting out sometimes, so.
Okay. No, cutting out isn't good. Hey, Walker, what do you prefer, Pascal's triangle or the NCR method when you're expanding?
I don't know. For me, I don't really have that much of a preference. I prefer to do Pascal's triangle or NCR. Like, I could really just go either way.
Oh, okay. All right. Well, what I've done here, what's in front of you, is kind of the simulation of both of what it actually looks like. So that you can see that the NCR, this is what you would plug in on the calculator. And these are the actual values that you would get. Okay. So you can see how they're similar to one another. It's just kind of each person's preference. To me, there's a lot going on in that Christmas tree over there with the NCR. And like I say, I think Miss Stone's just much more, she's not quite as lazy as Miss Sparks is. I like just those plain old numbers. They speak to me. But number 22 in the expansion of x plus 4 raised to the 4th power. Basically, we would be using this line in Pascal's triangle. And so our multiplier for the first term would be 1. And then our x would be raised to the 4th power. And our 4 would be raised to the 0 power, which is obviously 1. Then our second term would be, the multiplier would be 4. Our x would be raised to the third term because our x, this first term here, goes in descending order. And the second term goes in ascending order. So that's going to be 4 raised to the first power. So we have 0, 1 on it and 4, 3 on the other. The multiplier is going to be 6. And x is going to be squared. And the 4 is also going to be squared. Next, the multiplier is going to be 4. And the x is going to be to the first power. And the 4 is going to be to the third power. And our last term, the multiplier will be 1. X will be raised to the 0 power, which is 1. And 4 will be raised to the 4th power. So now, to get what that actual expansion is, we have x to the 4th power times 1, which is just x to the 4th. And then we've got 4 raised to the 1st power times 4, which is 16x cubed, plus, and we have 4 squared, which is 16 times 6, which is 76. Correct me if I'm wrong. I was just doing that in my head. And then we've got 4 cubed, which is 64 times 4, which I think is 256 because that's just 4. X plus, and then our final one is 256. And the one that they were looking for is the x. So it's 256 is the answer. How'd you do on that one, Walker? Emma got it right. How'd you do?
Fair.
Fair. All right, let's try another one. Are you still with us, Emma?
Mm-hmm.
Okay, cool. The next one is the third term in the expansion of x plus 3. And here's another little hint for you. You might want to look ahead on the test sometimes and see, because you'll see that we had x plus 3 to the 5th on number 21. So if we had saved our work, but maybe it's just good practice. What do y'all think? So we've got x plus 3 raised to the 4th power. So what line in Pascal's triangle would we use?
The fourth.
The 1, 4, 6, 4, 1.
Yes, good job. So in that first one, the multiplier is going to be 1, and x is going to be raised to the 4th power, and 3 is going to be raised to the 0 power, which really is just 1. And the multiplier for this next one is going to be 4, and x is going to be raised to the 3rd power, and 3 is going to be raised to the 1st power. And the next multiplier is going to be 6, and x is going to be raised squared, and 3 is also going to be squared, plus the next multiplier. Oops, my bad. The next multiplier is going to be 4x, and then 3 is going to be raised to the 3rd power, plus 1, and x is raised to the 0 power, which is really just 1, and 3 is going to be raised to the 4th power. And the question is asking us the third term. So this is 1, 2, 3. So it's looking for the third term. So what's 3 squared? That's 9. And 9 times 6 is what?
54.
So the third term is 54x squared. Did you get that one, Emma?
Mm-hmm.
Good. How'd you do on that one, Walker? Not to call you out.
No, I did good.
Not good?
No, I did good.
Oh, you did good? Oh, praise the Lord. I was like, oh, Lord, I really called him out. I don't want to do that. I don't ever want to make anybody feel bad.
Oh, no, it's okay.
Okay. All right, moving right along. The first term in the expansion of y plus 4 raised to the 4th power. Okay, this is, to me, just praise the Lord when you get one like that, because no matter where it is, your first term is always going to have that multiplier of 1, and it's always going to be whatever the first term is raised to the highest power that you can get. So what do you think the answer for that one is?
D.
It is. Does that make sense to you, Walker, or do you want to see it?
No, it makes pretty much. Makes
Okay.
sense.
All right. Once again, just stop me for anything that doesn't make sense. Ooh, number 25, expand completely. X minus 4y cubed. Okay, so what line are we going to use? Any takers? That's going to be your multiplier. Why did I pick that?
Because it's the third row.
Correct. It's the one that represents. So basically, the top of the triangle is 0, 1, 2, 3. So when counting from top to bottom, you always start with 0, and counting left to right, you always start with 0 in Pascal's triangle. Okay, for the total expansion, our first multiplier is going to be 1, and then x is going to be raised to the 3rd power, times, this one's going to be fun, 4y raised to the 0 power, which is really technically 1, but we got to be really, really careful with that -4, okay? The next one, the multiplier is 3. X is going to be in descending, so we started with cubed, now we're at squared, and here we've got -4y raised to the first power, plus, and our multiplier is 3, and our x is going to be raised to the first power, and -4y is going to be squared, plus multiplier is 1, and we've got x raised to the 0 power, which is really technically 1, and then -4y cubed. So now we got to go back through and address all the multipliers and stuff. So this first term is just going to be x cubed because it's 1 times 1. This value right there, the -4y is 1. So it's going to be x cubed plus, and then we've got -4y to the first power. So -4 times 3 is -12. So I could write plus -12, or I could go back and erase this and just do minus 12y. Does that make sense to you all?
Yeah, it makes sense to me.
Okay. Oh, oops, I forgot something though. I forgot my x squared. I got all excited about multiplying everything else. Plus, and now we've got -4y squared. So -4 squared is 16, and 16 times 3 is 48. So I've got a positive 48xy squared. Okay?
Mm-hmm.
Did I lose anybody? We still good? Now, I went ahead and wrote a minus because -4 cubed is going to be -64 because -4 times -4 is a positive 16, and 16 times a -4 is a -48 times 1 times 1 because that x raised to the 0 power is 1. And then I've got y cubed. So I've got -64y cubed. So my answer should be C, which is x cubed minus 12x squared y plus 48xy squared minus 64y cubed. How are you all feeling about this?
Makes sense.
Better.
Better, good. Are you feeling better compared to last week, Walker?
Yes, ma'am.
Okay, good. All right, good. I'm glad. All right, we got one more of these, and then the review tomorrow. Actually, we've got more of these coming.
Oh, joy. What fun.
I know.
I can hardly wait.
I know. It's very exciting, isn't it?
Mm-hmm. Are we doing anything special for Valentine's Day? Like, are we doing some sort of math trivia thing? Because it seems like every single time at Christmas or at Easter or something, there's always like some sort of...
Well, I have a review. Maybe I'll just throw out candy if y'all get them right.
That sounds good. Sounds real good.
Let me put a reminder on my phone. Hang on. Set a reminder for 5 p.m. today to go to the grocery store and get candy for Algebra 2.
Okay, I'll remind you.
See, isn't he good to me?
Oh, wow. It's British Siri.
Yes, I have a British Siri. He's my butler. He's Hobbs. Anyway, I just wish he cleaned better.
That's pretty good.
X minus 5y cubed. Okay.
Is it B?
I'm sorry?
Is it B?
It is B.
Thank the Lord.
Good job. Okay. So the multiplier for this, once again, we're using the same row. Thank you, Jesus. So the multiplier is going to be 1. And then we're going to have x cubed. Walker,
Yes.
do you want me to continue writing when it's -5, the second term to the 0 power. Is that helpful for you? Or can I
Yes.
leave that off? Okay. No. All right. Then I'm going to do exactly whatever makes everything helpful. I'm not leaving anything out. Okay. Then the multiplier is 3. And then we have x squared because x goes in descending order because it's the first term, and the first term goes in descending order. The second term goes in ascending order, starting with 0. Now it's raised to the first power. Plus the multiplier is 3, according to Pascal's triangle. And then we've got x to the first power, and then -5y to the second, because it's going in ascending, plus 3 times x to the 0, which really is 1, times -5y cubed. Okay, now we're going to go back and multiply everything out. This is just 1, so I have 1 times 1 to x, times x to the third, so we have x to the third, plus, and then this is -5y raised to the first power, so I've got -5 times 3, so that's technically -15. So I could put -15 x squared y, because I got to incorporate all of the values within that second term, plus, and now I've got -5 squared, which is -5 times -5, which is 25 times 3 is going to give me 75 x y squared. And then my final term here, I've got -5. Oh, oops, my bad. The multiplier is 1. I've got -5 times -5, which is which is a positive 25, times a -5 is -125 y cubed. So the full expansion is B. All right.
Alrighty. Makes sense.
Good.
Mm-hmm.
Okay.
So does this conclude the lesson, or?
Well, there was actually some more on it, which has to do with a lot of what we were doing yesterday in class. And I'm going to get you started on number 27, if that's
Yeah.
okay.
I see that right here for the other thing. I was just wondering because I have archery practice pretty soon.
Okay. When I actually have a second job that I have to leave to go to.
Oh, really?
Emma, how are you on 27, 28?
Good.
Okay. Are you okay on it, Walker? If I just get you started on the first one?
Oh, yeah. I think I've got that down pretty good.
Okay. All right. Because basically all that you're really changing is, you know, the NCR on that. The N is 25 and the R is going to change for each one. The A, the B, the C, the D. So it's like for A, it's going to be 25, choose 2. Does that make sense?
Gotcha.
Okay. And then your probability is 0.5 for each of them.
Mm-hmm.
Because it's flipping a coin and you got a 50% chance.
Gotcha.
And then number 29, it's a binomial distribution. So I'm going to actually do that one first in class tomorrow.
Gotcha.
Okay.
Yes, ma'am.
And then we'll work out another worksheet very similar to this one tomorrow.
All right. Makes sense.
We've had so many, people miss that we're just trying very hard to review because of the flu season.
Mm-hmm. There's a lot of people with the flu this year.
Yeah, it's been really, really bad. It's kind of sad. So that's why we're really hitting this whole week with review. So, I'll try to make it fun tomorrow.
Thank you so much, Miss Sparks.
No problem. Emma, are you good?
Mm-hmm.
Okay. All right. Thank you all for coming to Math Lab and
Thanks.
hanging out with me.
Bye.
Y'all have a good day.
You too.
Bye-bye.
Bye.